Hello, welcome to my one more new video. In this video, I am going to discuss about the preliminary design of beam. Here I am going to design the preliminary beam size. This is our architecture drawing. In the architecture drawing, there are so many beams. Here we have to be select the critical beam. That means the beam whose size is larger in the length, the longer beam. In the Here I am selecting here in this architecture drawing this line. This is our the longer beam. Here is the column and here is the column, and this is the longer beam, that is 8 EG is this our the longer beam. And here I am going to design this beam, and the length used in this with this architecture drawing the taken from the architectures. In the architectures we have used the dimension principle dim command to measure these dimensions. Here I have already calculated the dimensions, that is I have calculated preliminary design of beam. That is preliminary design of beam are also done from the have been done in the two way, from the for the diffraction criteria control and from moment criteria. First of all, we have to be designed preliminary design by the deflection criteria, taking the maximum span of them of the even in this architecture drawing, and then this is the beam 8EG has longer span. L is equal to 24 feet 8 inch converted into mm. Here you have to see the formula converting mm, and the grade of this concrete, use grade of concrete is Fe 500 at 500 MPa, and grade of steel is M2525. And assuming the percentage of steel in a beam, generally we have assuming 0.8% to 6% of steel in beam. I am selecting the 4% here, and from IS code 456 clause 23.2, alpha, beta, gamma, delta have to be assumed. How I am assuming? I am going to show you this the IS code 456 8000 2000. This is in the page number 37. You have to go this page number 37. There you got. Okay. In the page number 37, I am selecting this. There in the clause 23.21, the vertical deflections limits rather said generally to assume they satisfy the providing spans of the depth is not greater than the values obtained. The basic value alpha for the depth of the ratio span is less than our span is less than 10 mm. So we have to select this among these. For the cantilever beam, simply supported and continuous. Our beam is continuous because our beam has continuously from the both sides. So we are going to select the continuous beam, that is 26. So that's why I'm writing the alpha is equal to 21. Okay, and beta. Beta is for the span above 10 meter. The value may be multiplied by 10 by span in a meter, except for the cantilever. In this case, deflection criteria should be met. Here our span is less than 10 meters, so also beta is equal to 1. And depending on the area of the steel and the for the tensile reinforcement, the value of AB should be modified and multiplied with the modification factor from the figure 4. From the figure 4, First of all, we have to be, for the gamma, we have to first calculate Fs, that is 0.58% of Fy. 0.290, and percentage of still here I am assuming the 4%, and gamma is equal to 0.67. How I am going to again show from the figure 4 IS 456 2000. Gamma means the modification factor. The page number 38. In the page number 38, this is our graph. The page number 38. The page number 38, you have to go where you got the modification. There is the modification factor in the tensile, the graph this. Here our Fs is 290 and modification is greater than 4%, that is greater than 3%. That's why if they go in the straight line, so if the 4%, the 289 Fs, there is, you have to go there, is around 0.6 this, and it's around between the 0.6 and 8. So I'm going to select here alpha is equal to gamma is equal to 0.67. It is among the 6 or the 7 between, so 6, and this is depending upon and delta and lambda. Delta is the compression reinforcement and the other is this one. So that way we have ordinarily takes the 1 and 1. Okay, there, because the compression and tension side there is 1, so they have taken the 1, and I squared 456, this derivative for d by dx is greater or equal to 1 by alpha plus beta by gamma, and we have to calculate the d from this. D is equal to 431, have created this, d should be greater than 431 so I'm going to take 440 mm, and capital D, small d is our effective depth, and capital D overall depth is equal to, here take 14 mm effective cover and 20 mm diameter bar. So effective depth plus clear cover plus diameter of bar by 2, 490 from the movement criteria. Then we have to be designed for the movement criteria. Movement criteria, when the beam, in a beam the slab load is also concentrated, all the slab load are transferred into beam, so we have to be calculated the slab weight. Slab weight, that means gamma into capital D, that is gamma 25 into slab capital D, that is capital D. What is our capital D? In this slab we have already calculated 150, 130, I think 130. Want to take the gamma into D, we have calculated in the previous chapter with the slab depth, that you have to D into D by 1000, okay, and the plus the 2 element thickness, gamma into 2 element thickness, that is 20.4 gamma for the plastering, and marble for 26 gamma, and the 2 element thickness, and dead load total. Dead load is sum of this loaded, and we have to calculate for the kilonewton per meter. So multiply with length. Okay. So multiply with length, then you got gamma, the total load into length, that is in kilonewton per meter, and the live load is 2 kilonewton from IS code 875 for the residential building. Okay, you have to be going on IS code 875 IS code 875 part 2, table number 1. Then you have got this value. in IS code 875 part 2 1987, in the table number 1, for the residential I am already designing for the residential building, for the residential all the rooms and the kitchens. However, in our design where I am going to design, that is bedroom, kitchen, combination of bedroom and kitchens, draining rooms. So it's our criteria. It's fulfill this criteria. All the rooms and the kitchen, that is the live load is 2 kilonewtons, 0.2 kilonewton per meter cube. So I am taking 2 kilonewton per meter cube and live load, and you have, and it is our kilonewton per meter square, kilonewton per meter square, and you have to calculate the kilonewton per meter. So you multiply with length of beam, that is this. And wall load, for the wall load, what we should have to be done. Wall load, that is there is assuming 30% opening, okay, assuming 30% opening here. So the 70% consists of wall, that is 0.7 times wall, 19.6 gamma. Gamma of brick wall is equal to 19.6 into thickness of wall 115 mm, and by 1000 is equal to gamma, and multiply with height of the building, that is our height of the building is 2.85, and we have got kilonewton per meter square, and total load is equal to live load plus wall load, and ultimate load is equal to 1.5 times total load, and bending momentum for the beam is equal to W, the design load kilonewton per meter, uniformly distributed load, that is, and into L square by 8, and we have calculated the W U into L square by 8. We have got this moment, and mu is equal to 0.133 FCK. Here and formula, mu is equal to 0.133 FCK PD square. Assume B is equal to D by 2, P by 2, and T is equal to, then you have calculated using this formula, you have calculated D, that is mu by 0.133 into FCK, that is 25, and D is D by 2. I have calculated T, and T is greater than this, that is 700 I am assuming, and D is 750. D is 750. Okay, D, that is 40% cover and 20 mm diameter by 2, and we are selecting the greater value. Okay, among the both criteria you have to be find on different value. D effective date, and here D is 750, and the D is equal to 700, and D effective date 700, and the overall date 750, and B is equal to 350. Okay, and preliminary design of secondary. If you have a design for the slab or the secondary beam, so you have to be designed for the, if your slab depth is greater than 150 mm, then you should have to be designed for secondary beam, secondary slab, split the slab. So you have to be designed for the secondary beam. And the maximum, here you have to select the maximum span of them is 12 feet 4 inch, and deflection criteria you have to the 500 between similar like this. The 525 in the market most of the country have reached 500, so we have written the 500, and the percentage is 0.8 to 6%, that is 4%, and I scored for 26 continuously being for 26, and gamma bit less than 10 mm in the span 1, and gamma is equal to 0.6, that is 4%, and is always greater than 0.67, and gamma is equal to 111, and using the d by lx is greater or equal to 1 by plus gamma, that is, so d is equal to d, calculate, and d must be greater than d, and d is equal to d is greater than 150, that is 1 to 20, and small d is equal to d by 120 by 20. Effective depth vertical power 40 plus diameter by 2, and b is equal to 2/3 of capital D, that is b. So we have computed the size of beam, that is 180 by 270 for the secondary beam, and primary beam 350 by 750. Here we have computed. So thank you for watching this video. I think we have got the informations, the preliminary design of beam, and next video we are going to discuss about the preliminary design of column. Obviously we should have to be what this. Thank you.